see, do we need that? Some light, that looks good. All right, so that's how we're gonna label the sides, A, B, and C. And what the law of sines tells us is that the ratio of side little a over sine of angle A would equal the ratio of side B over sine of angle B. So when you see lowercase letters versus uppercase letters, that will make a big difference here. We want to make sure that lowercase denotes side lengths, angle measures are the capitals there. Or we can, certainly incorporate side C. It could have been something like B over sine B equals C over sine C. That would be an option that we would have for law of sines. And I guess the last scenario being A over sine A is equal to C over sine C. Okay, so if we jump right into this here, then at the bottom, what does law of sines do for us? It helps us to find side lengths and angle measures in non-right triangles. So if we had a right triangle, we could use SOHCAHTOA. If we don't have a right triangle, law of sines is there to help out. So let's see if I can bend this a little bit further down here. Okay, this first example here where angle A is 32 degrees, the measure of angle B is 100. If little c is 25 feet, what's little a? Okay, so here's my triangle ABC. And A is 32 degrees, B is 100, and little c, which goes across from angle C, is 25. What is the measure of side A? So based on that setup, what I would do is I would say, well, A over the sine of angle A, and by the way, don't think I didn't take home my fancy markers from class. Got those with me ready to go. Okay, so we've got A over sine of angle A here, so that would be A over sine of 32 would equal C over sine of angle C. But the issue is, well, right away we don't have the measure of angle C. However, I'm hoping that we can quickly identify that if I do 180 minus the two angles that are given, that would leave me with 48 degrees at angle C's location. So on the bottom of 25, we have to pair that up with sine of 48. So now that I have that all filled in, we can go ahead and with law of sines, you'll find that we cross multiply. A sine 48 equals 25 sine 32. And then a quick divide step here, divide both sides by sine 48. We get that the value of A is, I'm going to round this to the nearest foot. Hopefully you guys have a calculator at home. If not, there's a lot of different online or even app options on your phone, a lot of which are free. There are some paid options that I know are pretty good out there too for a pretty minimal cost, but hopefully you have some kind of calculator at home that can do sine on it. Okay, 25 sine 32 divided by sine 48. And the answer I'm getting here is rounded to going to be 18 feet. I would say if you're not getting this answer, I would definitely check that you're in degree mode. Since we're typing in angles and degrees, we'd want to double check that we're in the right mode. So the answer is 18 feet. Of course, if anything goes too fast, you guys know where that pause key is, I hope, so you can pause this as needed as you go throughout the process. Okay, going on to the other side in number 2, we have, just I want to reference here that we have degrees and minutes. So I'm going to remind you where that is on the calculator. So if I have triangle ABC again, with little a is 10, little b is 13, angle A is 62 degrees, 10 minutes. We want to find the measure of angle B. So in order to do that, looks like we have enough info from law of sines. I would say 10 over the sine of 62 degrees, 10 minutes is equal to 13 over sine B. So if we cross multiply here, 10 sine B is equal to 13 sine 62 degrees, 10 minutes. And then in this case, we are still, after cross multiplying, going to divide. This time I'm dividing by 10 though. I'm going to isolate sine of B first. So if I do that, we get 13 sine, and then to type in degrees and minutes as a reminder, type in the 62 first, second apps, first choice is degrees, and then we've got 10 second apps minutes. Okay, so once I have that typed in, I'm going to then divide that by 10 to get that sine of B is 1.1496. Okay, so to find angle B, I would then do sine inverse of that, and maybe some of you are already thinking you'll know what happens here. Because what should happen if I do sine inverse of a number bigger than 1, if sine's opposite over hypotenuse, you're going to get this error message on the calculator. which essentially then draws the conclusion in this scenario that angle B doesn't even exist. So these measurements can't actually create a triangle, and we're going to come back to that later in another lesson. What we have right now is we have side-side angle, and side-side angle doesn't always guarantee that a triangle can be formed. We're going to talk about that in a future lesson called the ambiguous case. If you check the filled-in notes, I might have actually changed one of these values up here to make angle B work out, but don't worry, if you flip the page, I'm sure we're going to find an angle that does work in the very next question. So in this example at the top here, it says that we have a derrick at the edge of a dock. So that's this thing right here. And it makes an angle of 122 degrees with the floor of the dock. Based on some other measurements that are given, the cable that it's being braced with is 40 meters long. We want to determine how far from the edge of the dock must the cable be fastened. So that's this distance right here. So in order to find that, if I'm going to use that law of sines idea, I need to know the angle across from it, which right now is not known to us. So if I look at the given information, the only thing that we have enough info to find right now is actually where angle beta is located over here, because I know the side across from angle beta is 25. So I'm going to find angle beta first, and then hopefully you'll see what we're going to do from there. We're going to do 40 over sine 122 equals 25 over sine of beta. Okay, if you want to change it to a b at some point, I'm not too offended here. Lots of Greek letters in this one. So if we cross multiply, we get 40 sine beta equals 25 sine 122. Okay, just like we saw in the last question, divide by 40. So sine of beta is equal to, and again, as long as this ratio is under 1, we should be good to be able to calculate the measure of angle beta. So 25 sine 122 divided by 40 is 0.5300. Okay, so if you do sine inverse of that on the calculator, it's going to give you an angle. And we'll go to the nearest degree here. In fact, it will come out actually pretty nicely to the nearest degree. It rounds just to about 32.007 degrees. So I'm pretty confident we could just call that 32. And now that we call that 32, I'm pretty sure that's gamma up there. I'm remembering my Greek letters, but you guys can double check me on that. So now I can find this angle, I'll call it gamma up there. To find that angle, I know two angles in the triangle, 122 and 32. So if I subtract from 180, you would get that there's 26 degrees left up here. So now that I know that that's 26, we'll do law of sines one more time to find the length that we've called x. So x over sine 26 is equal to 40 over sine 122. Okay, and once you get the law of sine set up, cross multiply, x times sine 122 equals 40 times sine 26. Divide both sides by sine 122 to get that x equals 40 sine 26 divided by sine 122. Let's see. I'm getting that x equals 20.676. So we'll round up to the nearest meter here and say that the length there is about 21 meters. Okay. So there's a quick application using law of sines. I kind of like this because we had to use law of sines twice, and we got that practice finding an angle measure using law of sines. Okay, moving on to the bottom. There's not a question associated with this yet, but the last two questions in the notes deal with the angle of elevation and depression concept. These are topics that, again, maybe you would have been familiar with these terms from geometry. Angle of elevation is measured from either a point on the ground or maybe a line of sight from a person standing on the ground up to an object in the air. And the angle of depression is therefore the angle from something you're let's say up in a plane or up on top of a mountain, a lighthouse. We'll see questions that involve probably all those things. It's the angle of depressions, it's not going to be inside a right triangle. It's actually the angle formed on the outside of it with the hypotenuse and a line of sight drawn directly parallel to kind of ground level. And due to the fact that this line of sight is always going to be parallel to ground level, we know that the angle of depression and angle of elevation are equal to one another. They're congruent. Because if you have parallel lines, get ready for some geo real quick here. That implies that we have congruent. And if you remember, these would be alternate interior. angles. Okay. Not that you really had to know that, but just as a quick aside as to why that's true, parallel lines create those congruent alternate interiors. Okay, so that'll bring us up to the last two questions then. We'll walk through these, and then hopefully this video is not upside down. Fingers crossed. Okay, so while traveling in Egypt, Mr. All is walking towards the Great Pyramid. At a certain point, he stops and measures his angle of elevation to be 38 degrees. So I was right here to start, and then I stopped. And I'm like, hey, there's a pyramid, angle of elevation 38 degrees. Then I walk 200 feet closer, stop again because it's hot and I'm tired, of course. And my new angle of elevation is 51 degrees. Find the height of the Great Pyramid. So the height of the Great Pyramid can be modeled by this height that I've kind of repeated outside to create it a right triangle there. And then to the nearest foot is where we're going to round in this case. Okay, these double triangle problems, I'll tell you, they get set up pretty similarly. So when you see a picture or a diagram that looks like this, I always kind of default to thinking of law of sines, which I'll abbreviate as LOS twice. Okay, so when you see me write LOS in future notes, law of sines, if you do law of sines twice, that should be good enough to get you the answer. And I'll tell you, a good goal to establish for yourself is to find that shared side first. So this side right here that connects these two triangles, if you can find that side, well, that's kind of critical because that's the side that connects these pieces. And I'll tell you, we can find this side in the triangle on the left, the obtuse triangle, because that's the only triangle we have a side length in. So in order to set up law of sines, it would be x over the sine of 38 equals the 200, the side that I know, over sine of, well, I got to figure out what that angle is up here. And I'm hoping you're seeing the connection that since I'm walking kind of in a straight line towards the pyramids, that these two angles would be supplementary. So this angle would be 180 minus 51, which is 129. And I better double check that because, you know, that's the tough part here. That is 129. And if I add that to 38, the other angle, it's a total of 167. So subtracting that from 180 gets you the last angle of 13. So that is the angle that you need if you're going to use law of sines here. So then we're going to cross multiply x sine 13 equals 200 sine 38. Divide both sides by sine 13. Not going to be our answer right away, but it is going to be a number that we use to get the answer. 200 sine 38 divided by sine of 13 is 547.37 something. So I'm just going to write 0.37 dot 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 to say, hey, that decimal goes on for a long time, but I'm going to have you save that on the calculator. Don't delete that out yet because we are going to use it in the next step. So in the last step, now I'm going to move over to this right triangle here. And I like using law of sines again because that's kind of a big focus in this unit. Although if you have a right triangle, you could use SOHCAHTOA to find the side that we've labeled H right here. But if I know the side X is 547.37 dot dot dot, I could put that over sine of the opposite angle, 90, right triangle. And then that would be equal to H, the height of the pyramid, over sine 51. Okay, now cross multiplying in this case, you can certainly solve it the same way that we did up in this example up here. However, I'm hoping you might recognize that sine of 90 from what we just did with identities and with unit circles and trig graphing, that's really just 1. So I'm really doing, when I cross multiply here, h times 1, which is h, that would equal 547.37 dot 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 times sine 51. So if you still have that number on the calculator, your 547 number, multiply that by sine 51. We get that the height is 425.38. So to the nearest foot, we'll say that it's about 425 feet. Okay, so even though that's the answer to this question, I'm sure your natural curiosity, you would have Googled this even if I didn't tell you, but the actual height of the Great Pyramid in Egypt is 455 feet, approximately. So Mr. All was a little off in his calculations. I'm guessing after my 200-foot travel there that I was weary from walking that far. So maybe I measured the wrong angle of elevation there. But All right, anyway, so there's a quick angle of elevation problem. Just to finish off these notes, we'll do an angle of depression. I'm quite the traveler. Not only did I go look at the Great Pyramid, but I also went skydiving to follow him. And I don't know if I would ever do this in life. I don't know. I've never gone skydiving. Maybe you guys have. But so if I am skydiving and I probably want to land somewhere. So I'm noticing that my angle of depression to this landing area, to the beginning of the landing area, and then to the end of the landing strip are 11 degrees 40 minutes to the end, and 20 degrees or 22 degrees 15 minutes to the beginning of it. So here I am again, and this time I'm jumping out of a plane, so I guess I need a parachute. This is terrible, but let's see. Can I attach it to myself? There we go. Sure. So I'm traveling down, and I'm here, and I, of course, would have noticed that, hey, there's this landing area down here that I can land in. And sorry, I'm going to turn this for a sec. Okay. So the angle of depression that we're talking about here, sorry, this is the ground, so that's flat. Okay. The angle of depression is this angle formed by my line of sight. And to the end, we said that that was 11 degrees, 40 minutes. Now, what I'll ask you to do is as soon as you label the angle of depression, you kind of copy it to where the angle of elevation is. So from the ground up to this point, the angle of elevation would be the same. Okay, now that I have that in there, the other angle, just, I know it's a little bit tougher, but it's from that same line of sight all the way through here. That's the 22 degrees, 15 minutes. So if I were to copy that part over, I kind of need to extend the ground out. Maybe I'll drop a vertical from where I am and call this whole thing 22 degrees, 15 minutes. Okay. So that's what the picture's starting to look like. What I know is that the plane is 2,500 feet above the ground. How long is this landing area? So it's actually the opposite of what we had up here. In this case, I knew the horizontal distance. I didn't know the vertical, the height. But now I know the height of the plane since I'm jumping from it. And I'm trying to find what is this length of this landing area. Okay. So in order to find that, again, you probably want to default to finding the shared side first. Let's get some funky colors going at the end here, just for fun. Okay. So I'm going to call this y. I don't know if you can tell it's a different color or not, but to find y, I can set up some law of sines. It would be y over sine of 90 would equal 2,500 over sine 22 degrees, 15 minutes. So if we cross multiply, we get y sine 22 degrees, 15 minutes equals, remember, sine 90 is 1, so that's just going to be 2,500. Okay, divide by sine 22 degrees, 15 minutes. And kind of leave this number in the calc for a second. So 2,500 divided by sine of 22 second apps degrees, and then 15 second apps minutes is, let's see, so I'm getting 6,602, something like that. Okay. And then if I leave that number in there for a second, then the last part is to find what we've labeled as x. We can set this up with law of sines again and say, okay, well, y over sine of 11 degrees, 40 minutes would equal x over sine of this angle up here in this little skinny part of the triangle. So to find that angle, you can do a few different things, but maybe the easiest way is just finding the difference in those angles of depression. That would actually be what's left over in that blue part that I've highlighted. So if I do the first angle of depression, 22 degrees, 15 minutes. Oops, don't hit enter. But anyway, if I subtract from that 11 degrees and 40 minutes, was that what it was? Yeah, 40 minutes. Okay, so you get this number in decimal form, but if you'd like to write that, I don't really want to write 0.583 repeating as the measure of the angle. So one more time, second apps, choice 4 converts it to degrees, minutes, seconds. And now I know it's 10 degrees, 35 minutes. So since this is 10 degrees, 35 minutes, you would do x over the sine of 10 degrees, 35 minutes. Hey, by the way, instead of calling this y up here, why don't we actually say that y is 6,602, because that's the number that I'm going to use when I cross multiply here. Okay, so we get x times sine 11 degrees, 40 minutes. That equals my 6,602 times sine 10 degrees, 35 minutes. And if you divide both sides, finally, by sine of 11 degrees, 40 minutes, then we get the length of this landing area. Hopefully I'm going to make it. Is, let's go back up and grab that 6,602 number, the value of y, hit enter, times sine 10 degrees, 35 minutes, divided by sine of 11 degrees, 40 minutes. I got 5,997-ish feet. And if you remember anything about converting from feet to miles, that's just going to be probably a little bit longer than a mile, because a mile has 5,280 feet. So hopefully with my non-advanced skydiving skills, it's a big enough landing area for me to make it there. So, all right, that's the first video. I really hope this worked this time. I really hope you guys are finding a way to create a new normal for yourself at home for the time being, and you're managing the work that's coming in from all your different teachers. Stay tuned for more videos and more updates from me, and I'll be in touch. I'll send you guys an email letting you know that this video should now be available for review. All right, we'll see you guys soon. Bye.